Hi, I am Daniel Gretzky, and today I'm going to talk about peer-to-peer charging infrastructure built with blockchain technology. In today's world, we have an increasing amount of electric cars on the road, but the charging infrastructure itself is still lacking. In Kaiserslautern today, we have 22 gas stations, but only 9 charging stations for electric cars. It also takes a longer time to charge an electric car than to fill up a traditional car with gas. City residents also know the problem that they don't always find a parking spot in front of their own home where they could conveniently charge their car. An alternative to these public car charging stations could be a peer-to-peer sale of electricity between a car owner and a homeowner. A homeowner could act as a charging station operator who sells electricity to an electric car owner who parks in front of their house. Ideally, both parties wouldn't have to meet to conduct the transaction. Smart devices like a smart plug and a smart socket could be used to control the charging and payment process. Since in a peer-to-peer transaction, both parties are private persons, trust is an issue, and an adequate payment solution has to be found. The traditional approach of having a cash register doesn't work for obvious reasons, and we have to use an electronic payment system. But here we encounter the following problem. If the customer pays first, he risks not getting any electricity in return. And if the seller delivers electricity first, he risks not getting paid. Payment solutions like Visa and PayPal are often used to mitigate that risk. They act as a trustee, and the seller trusts them to receive his money once the service has been performed. On the other hand, the customer trusts them to receive his money back once he hasn't received any goods for it. Still, both parties have to trust one company, and risk cannot be ruled out entirely. Lastly, these electronic payment systems have not been designed with machine-to-machine payments in mind. In the area of payment solutions, terms like blockchain and cryptocurrencies are getting increasingly popular. To understand why they could be a viable solution, I'll give you a short introduction into this topic. Cryptocurrencies and blockchain technologies are also often called programmable money, and they're very convenient for IoT applications. So what's the main difference between cryptocurrencies and traditional fiat money? Traditional money is controlled, issued, and governed by a central authority like a central bank. Cryptocurrencies are giant computer networks that are controlled democratically by voting. The second difference is cryptocurrencies are transparent. They are based on a ledger which keeps track of all balances of every participant. When a transaction occurs, the state of the ledger changes. Every participant on the network has a copy of this ledger. This means that cryptocurrencies are highly transparent because all data is public and no trust is required because every participant can verify all data. Lastly, cryptocurrencies are immutable. This means that once a transaction has taken place, it cannot be rolled back. What does this mean for a car charging solution? Well, cryptocurrencies are practical for machine-to-machine payments, and there is no need to trust the company. Also, the immutability removes the risk for the seller, because once he's received his money, it cannot be taken away anymore. But how can we reduce the risk for the customer? Well, we reduce the customer's risk by reducing the monetary value at risk. If the customer sends money every 15 seconds to receive 15 seconds of electricity in return, he would only risk a fraction of a cent if he wouldn't receive electricity for his payment. Although cryptocurrency transaction fees are usually lower than, for example, PayPal's, sending 4 transactions a minute is still economically not feasible. Here the cryptocurrency Ethereum comes into play. It extends classical payment blockchains like, for example, Bitcoin with decentralized computing. Computer programs, also called smart contracts, run on Ethereum. For this, Turing-complete computer code is uploaded to the blockchain and can be run by every participant on the network. And it benefits of all strengths of the blockchain. It allows for decentralized, transparent, and immutable execution of code. This can actually help us lower transaction fees, and I'll show you how. With smart contracts, a so-called payment channel can be implemented. It can bundle multiple recurring transactions into just a few transactions on the blockchain. The smart contract is the independent third party that acts as a trustee for the transaction. Because both parties can verify the public rules set by the code, both parties can trust the process. First, the customer deposits money into the smart contract similar to a bank. Then, the customer sends the equivalent of a check to the homeowner. It includes a digital cryptographic signature which can be verified by the seller. You can also verify that the check is covered. Once the validation completed, he can start delivering electricity for the checks. At the end of the transaction, the homeowner can cash in the checks for the agreed amount of money. If the seller fails to submit any valid checks, the car owner can withdraw all his money again. Using this process, any amount of transactions can be broken down into 2 transactions on the blockchain, costing only a few cents. The first one depositing money into the smart contract, and the second one which cashes in the checks and distributes the deposited money accordingly. Now I want to show you how a real-world application could look like. An app could be used to find nearby charging stations. Once you're connected to your smart outlet, you can choose a maximum time you want to charge your car. After this, the payment channel is initiated. A transaction is sent to the Ethereum blockchain with the deposit. The transaction takes approximately 15 seconds to be completed. Now you can see that the transaction completed and the charging process started. The car and the socket are now connected over the payment channel. The plug now sends transactions every 15 seconds directly to the socket. After every transaction that the socket receives, it delivers electricity for another 15 seconds. After 8 hours, when the deposit value is reached, the payment channel would close automatically. The payment channel can be also closed at any point before that. Now the payment channel closes and the charging process is complete. Closing the payment channel sends another transaction to the Ethereum network, which takes roughly 15 seconds to process. Now that the payment channel is closed, the homeowner receives the specified money and the rest is returned to the car owner. That's all for the demonstration. Thank you very much for your attention.